Moving on to binomial problems advanced. Okay, so clearly you need to do binomial problems basic first, and once you do that, this is going to be a lot easier. Here in the first example we're going to look at, it says a machine manufactures automobile parts, or a machine that produces automobile parts makes defective parts 12% of the time. If 10 parts produced by this machine are randomly selected, what is the probability that at most one of the parts are defective? Carry intermediate computations to at least 4 decimal places, round your answer to at least 2 decimal places. Okay. I would try to not even carry intermediate computations at all. We'll try to use our calculator to get the best answer so we don't have to mess around. Well, so I would start by what it's asking. What is the probability that at most one of the parts are defective? So we want to find the probability that at most one part of 10, right? We're choosing 10. One part of 10 are defective. Now, it's really important that you wrap your head around what at most 1 of 10 means. I think you would agree that if at most one of the 10 parts could be defective, that means 1 is the biggest number of parts, or the most number of parts that can be defective. I don't want to have 2 or 3 or 4 or 5 or more defective parts. At most only 1 could be defective, or none. So you have to consider that. So the probability that at most 1 of 10 parts are defective is the same as finding the probability that no parts are defective, plus the other possibility that 1 part is defective. So these are the only options. I can have no parts defective, and I can have 1 part defective that would qualify as being at most 1 of 10 parts being defective. I don't want more than 1 part being defective. So if I found the probability that none are defective and added that to the probability of 1 part being defective, then we'll be in business. So now this is just like what you did in binomial problems basic. If I want no parts defective, that means I want out of the 10 total to choose no defective parts. And by the way, I know it sounds weird, but we're going to let like a success in this problem means actually a defective part. I know that doesn't kind of sound like it should be right, like it sounds like that's a failure if a part's defective, but for the sake of setting this problem up, we're going to make the success be a defective part, and a failure is a non-defect part. So here, if I want no parts defective, I have 10. I'm choosing no successes. Now, the probability of success, meaning the probability of defective part, the probability P from if you watch binomial problems basic, is 12% or 0.12. So the probability that we're going to have a defective part is 12% or 0.12, but we're raising that to the 0 power because we don't want any defective parts. And then we have to do 1 minus 0.12. That's the probability of failure, which is really a non-defective part. And we're going to have all 10 of the parts be non-defective. So in other words, 10 choose 0, and then 0.12 to the 0, and then 1 minus that is 0.88 to the 10. That's the first part. Plus, the second one is 1 part is defective. So that means out of 10, I'm choosing 1 to be defective. The probability of being defective is 0.12. Now I have only 1 defective part, so it's raised to the first. And then it's 0.88, the probability it's not defective, to the 9th power. There'd be 9 non-defective with only 1 defective. So you could type this into your calculator. 10 choose 0 though is like how many ways can you choose none of 10? That's just 1. 0.12 to the 0 is just 1. And then 0.88 to the 10, I don't know that. So I have 0.88 to the 10th power. And then I know that if I have 10 things choosing 1, there's 10 ways of doing that. You could type that into your calculator if you wish to double check me. 0.12 to the first is the same as 0.12. and then 0.88 to the 9. So if I were doing this, I would use my Alex calculator, and I would just simply type in 0.88, raise that to the 10th, right? Because 1 times 0.88 to the 10th is really just 0.88 to the 10th, plus I have to do, let me clear out of the exponent there, plus 10 times 0.12, and then 0.88 to the 9th, and I hit enter, and that's my probability, and I have to round to at least, round your answer to at least 2 decimal places, which is interesting. It says to at least 2 decimal places. Let's go to 2 decimals. 0.66 would be 2 decimal places. So the probability that at least one of the 10 parts is defective is 0.66. Let's look at another one, and it is important to check this one out. It's a little bit different, and if you don't see the shortcut, you're going to want to wish you did. It says the unemployment rate in a city is 11%. If 9 people from the city are sampled at random, find the probability that at least 2 of them are unemployed. And again, it says round your answer to at least 2 decimal places. Okay. We want to find the probability that 2, or I should say at least 2 of 9 are unemployed. That's like where I'm going to start off with, right? I want to find the probability that at least 2 are unemployed. Well, if you think about that, at least 2 means I have to find the probability that 2 are unemployed, and then add that to the probability that if it's at least 2, it means 2 is the smallest. It could go higher. That means it could be 3 that are unemployed. And then add that to the probability that 4 are unemployed, plus 5 and 6 and 7. We'd have to keep on going until we get the probability of 9 are unemployed. Now, I don't know about you, but that seems like a crazy amount of work. Like we'd have to literally add all those up and do all those probabilities. That'd be a ton of work. Okay, so I'm going to show you a shortcut to this so that hopefully you can cut to the chase. All right. I think you guys would hopefully agree that all combinations or all possible outcomes would be if I did like the probability that 0 are unemployed plus the probability that 1 are unemployed. I'm just going to go probability of 1 to save my writing here. Okay, so the probability of none are unemployed plus the probability that 1 person of the 9 are unemployed plus the probability of 2 are unemployed, and you keep on going, and you'd add the probability that all 9 are unemployed. So if I carried that out and I did the probability of nobody is unemployed to the probability that are all 9 unemployed, I think you would agree that's got to be 100%. These are all possible. It's got to be one of these things, right? I mean, if I pick 9 people at random, it's either going to be nobody's unemployed, or 1 is, or 2 is, or 3 is, or 4 is, or 5 is, or 6 is, or 7 or 8 or 9. These are all possible ways. All these probabilities have to add up to 100% because one of these things is certain to happen. So if you think about it, we wanted to get just this chunk of the equation. We want to add together the probability of 2 people, or 3 people, or 4 people, or 5, all the way up to 9 are unemployed. Well, if I add all this and it equals 1, I think you would agree that if I just subtracted the probability of nobody being unemployed, and I also subtracted the probability of 1 person being employed from both sides of the equation here, I would end up with what I want, which is the probability of at least 2 would be 1 minus the probability of 0 are unemployed minus the probability of 1 person being unemployed. So I just found what I wanted in a much tidier and easier way. So it's just going to be 1 minus. Now the probability of nobody being unemployed would be 9 choose, no successes. Now the probability of that person being unemployed is 0.11. So that's like my probability of success, be raised to the 0 power. And then the probability that somebody is employed would be 1 minus 0.11, which is 0.89. And I'd have to have all 9 of them there. Then I'd have to subtract the probability of 1 of those 9 being unemployed. So that'd be 9 choose 1 person to be unemployed. And then a probability of unemployment is 0.11. I have to raise that to the number of unemployed, which would be 1. And then it'd be 0.89, that's the probability that you are employed, raised to the 8th. That's how many people then would have to be employed if one was not out of a group of 9. And this would be the calculation to throw into the calculator. A lot easier than trying to add a whole bunch more of those combinations. Thanks for watching. Hope this helps.